Good afternoon, all the viewers from YouTube and Zoom, and welcome to the INYAS SIPP lecture series. And today's lecture is a tribute to Dr. Raja Ramanna, a main architecture of Indian nuclear program, on his 96th birthday, which sorry, there is some issue. So today's lecture is a tribute to Dr. Raja Ramanna, a main architecture of India's nuclear program on his 96th birthday birth anniversary, and which is about 2 days back. And today we have with us Dr. Swaminathan Kailash, former Director of Physics Group, Bhabha Atomic Research Center. He will talk about Dr. Raja Ramanna. So before handing over to him, so I'll just give brief introduction to today's speaker. Dr. Swaminathan Kailash, former Director of Physics Group, Bhabha Atomic Research Center, is currently in senior scientist at the University Mumbai DAE Center for Excellence in Basic Science in Mumbai, and he graduated from University of Madras and got his PhD degree from in nuclear physics from University of Mumbai. His keen interest in many fields, mainly in oscillator-based nuclear physics and related applications, and he is a fellow of several academies, and he has more than 250 international journal publications, and he is an excellent teacher and a mentor for many young nuclear physicians in the country, and we are very happy to listen him, and his long association, and he has seen Dr. Ramanna's working, and through how he'll explain us about his life and achievement. So with this small introduction, I will request Dr. Kailash to deliver his talk. Over to you, sir.
Thank you, Dr. Prakash, for your kind introduction. Good afternoon to all of you. I considered it as a rare privilege that I got this opportunity to speak about a great personality like Dr. Raja Ramanna. And I thank INYAS for inviting me to deliver this talk, coinciding with his 96th birthday. Even though I was not fortunate to work professionally with Dr. Ramanna, I got some reminiscences from distinguished scientists who had known Ramanna very closely for many decades. So that also I will try to convey to you their reminiscences as part of my lecture. So Dr. Ramanna, one of the distinguished scientists of this country, nuclear physicist, he was born to V Ramanna and Rukmani Amman, and he was his birthplace was Tumkur in Karnataka, 28 January 1925. And the father was a judge, and mother, of course, was a housewife. But you will be surprised that even at that period, she was very keenly interested in English literature. That had an influence on Dr. Ramanna and his upbringing. Ramanna, of course, had his early education at Tumkur. Then family shifted to Bangalore, and he continued his education there. Of course, he started with Bishop Cotton School and then went to St. Joseph School, both convent schools. And the advantage of these schools was that you could pursue his interest in music, particularly Western music. And Ramanna took interest in piano learning right from his young days. It is mentioned that the Maharaja of Mysore invited him to play piano in the palace even when he was a young boy, and appreciated him for his proficiency in piano playing. Ramanna went on to pursue his higher education at Chennai, the famous Madras Christian College, and got his BSc Honours degree in physics from the Madras Christian College. And then he went on to pursue his higher education in nuclear physics. So he went to King's College London on a scholarship. And I believe his main thrust was on design and development of gas ionization detector to measure the angular distribution of ionizing particles. Obtained his PhD in 48, at the age of say 23. And Dr. Homi Bhabha, the father of our atomic energy program, I think he was visiting UK, and there was a meeting between Ramanna and Bhabha, and Ramanna was offered a job by Bhabha, and Ramanna accepted this offer, and he came back to India and joined the Tata Institute of Fundamental Research in 1949. Of course, India was planning to build one research reactor, the first in Asia, I believe, and Apsara reactor. And when Ramanna came back, after some time in Tata Institute, he was shifted to Atomic Energy Establishment at Trombay. And Ramanna started working on some aspects of this upcoming reactor. So Ramanna was familiar with reactor physics, nuclear instrumentation, besides nuclear physics. So he was doing a number of studies related to the upcoming reactor. Then, of course, when the reactor got commissioned in 1956, Ramanna started using the reactor and did some pioneering experiments, particularly neutron-induced fission. Of course, Dr. Kapoor was closely associated with him right from his early research at Trombay. For those who, of course, I think most of you are familiar with what is nuclear fission. Just for completeness, when a neutron interacts with uranium target, it splits into two fragments, and some 2 to 3 neutrons are also emitted. This is the phenomenon of nuclear fission. As you know, it was discovered more than 80 years ago, and it involves large-scale collective motion of almost the entire nucleus, all the nucleons in the nucleus. And this phenomenon, even though it has been continuously studied for the last 8 decades, and it is interesting even today. Even now, many are pursuing this field of research because there are still open questions which are not fully. So we have a good understanding of fission phenomenon, but there are still surprises and there are still some new effects which come into play. So this field is still interesting even after 80 years. What I wanted to say, particularly in the light of Dr. Ramanna's studies in the 1950s, 60s, early 60s, that will be clear if you see how the nucleus undergoes the fission. A deformed nucleus like uranium, when it is stretched due to whatever process, it goes through a stage of evolution of greater and greater deformation. And we have different decision-making points. One of the decision-making point is called the saddle point because it has the shape of a saddle, horse saddle. And you can see already the two. You can see that the nucleus is to start with like this and then stretches into some more deformed shape. And then there is a neck between two nascent fragments, which will finally come out. And then next stage is, you can see the neck is becoming narrower or thinner. And then the two fragments you can see prominently. And the next stage, of course, the neck ruptures and the fragments fly out. So this is just in a simple way to understand the fission process. Of course, for us, it takes place instantaneously, but it has some time scale. What we have to appreciate in these different stages of evolution of the fissioning nucleus, you have neutrons and gammas emitted from the different stages of fissioning nucleus. And Dr. Ramanna and colleagues' work is related to this study. Particularly, they measured the neutrons and gammas emitted during the fission. And also, they estimated the time taken to go from saddle to scission, the different stages of the fissioning nucleus, is of the order of 10 power minus 20 seconds. You can imagine such a short time scale, which they could deduce from their work. And the setup they used in the late 50s or early 60s, this is the Apsara reactor, and the neutron beam comes out here. And here they put the detector, and you can see that the uranium target is inside here. So the neutrons hit the detector, and inside of one of the cathodes of the detector, they have the uranium coated, and then the fission is initiated here, and this is filled with gas. So the fission fragments travel here and ionize, and then this collected here. And this is how the fission fragments are produced and detected. And there is, of course, a photomultiplier, scintillation detector to register the fission events. And they also put a neutron detector in line with the fission direction. And this consisted of a plastic scintillator and a photomultiplier. And so they were measuring the fission fragment kinetic energies, fission fragments, the neutron energies, and neutrons and fissions in coincidence. You can imagine such a very complex experiment, and they could at least plan and do it in the early 60s. Of course, this they could do because Ramanna's PhD was related to development of detector, and he was detecting ionizing radiation with this kind of detector. So he used that expertise when they started the neutron-induced fission work at Apsara reactor at Trombay. So they measured the fission fragments and their energies, measured neutrons emitted in fission, keeping the neutron in the line of the fission direction. From the analysis of the neutron spectra, this is what they could deduce in coincidence with the fission fragments. They found, well, most of the neutrons were emitted from fast-moving fission fragments. About 10% of these neutrons were emitted also from the slow-moving fissioning compound nucleus. This is very, very important result. And normally, one would have said it is some kind of experimental uncertainty and left it there. But Dr. Ramanna, Dr. Kapoor and colleagues, they felt it was an important deviation. And they were bold enough to say that 10% of the neutrons were emitted from the compound nucleus, while the remaining were emitted from the fast-moving fission fragments. And of course, they also estimated the time taken from different stages of the fissioning nucleus. They also measured prompt gammas along with fission fragments in this thermal neutron-induced fission. And the measurements concluded the fission fragments acquire angular momenta when they go through different stages of fission. From saddle to scission, they also acquire angular momentum. They also measured alpha, but this work was done using the cascade generator, which was at Tata Institute, using the 14 MeV neutrons. They also measured again, alpha particles emitted in fission of uranium, and fast neutron-induced fission. And they concluded alphas were emitted at the scission point, probably from the neck between the two nascent fragments. Again, it's very interesting. Many of these findings we are also somewhat repeating, but of course with the better precision and more new insights. But the pioneering work was really done by Dr. Ramanna and colleagues. Another notable area where Dr. Ramanna made, again, very important contribution. And this work, Dr. Ramanna was joined by Dr. Ramamurthy, who was his student, PhD student. As you all know, the fission fragment mass distribution is one of the important aspects of nuclear fission phenomenon. What is plotted is the fission yield, and on the x-axis you have the mass number, which tells you the fission fragments are having this kind of shape. It is not just two masses. There is a distribution of masses, one somewhat relatively light, peaking around 90, another mass peaking around 140. So a nucleus like uranium, which is a mass number of 235, so when it splits into two, when thermal neutron is used for fissioning, then it splits into one of mass around 90, centered around 90, another of mass centered around 140. And of course, if you increase the energy of the neutron, this is what you found when thermal neutrons were used. However, if you use fast neutrons like 14 MeV or that kind of high energy neutrons, then you can see this valley which was there gets filled up, and you see more or less symmetric mass distribution. So this is something which is a very important and interesting aspect of nuclear fission. And Dr. Ramanna, Dr. Ramamurthy and others worked on this aspect and came up with a theory to understand this feature. Basically, it is an interplay between liquid drop and single particle aspects, which is of course a recurring theme in nuclear physics and more so in nuclear fission. So Ramanna proposed a model basically to ask the question why they are centered around 90 and 140. So he used the random exchange of neutrons between two nascent fragments. Again, the probability idea. Of course, this is the Markov process. That is the probability is decided by what is happening at that stage rather than the previous history. So they use this kind of probabilistic feature and random exchange of neutrons. And basically, if you have two fragments, they have not still split into two. You have a neck between the two, and you have neutrons in this, and they are randomly exchanged between the two nascent fragments. And so Ramanna and colleagues developed some kind of random exchange of these neutrons. And I don't have a figure. In their paper, they have shown the mass distribution can be reasonably understood by this kind of model. Of course, they introduced the importance of the shell closure. You know that nuclei with this kind of proton number or neutron number, 2, 8, 28, 50, 82, 1, they're called magic numbers. They have extra stability, they have more isotopes, this kind of things. So they used whenever one of the fragment has a neutron or proton number or neutron number close to the magic number, then that acts like some kind of barrier. So that also has to be kept in mind in this exchange of particles between the two. So the shell closure or shell effect also should be taken into account. And they use both this and then they could sort of give a reasonable explanation of the mass distribution. So this is what I would like to say, that even 60 years ago, they could do this kind of remarkable work on nuclear fission, both experiment and theory. And they have stood the test of time. And even today, the results are consistent with whatever we do today. So Dr. Ramanna, of course, continued his work. And you all know that after the untimely demise of Dr. Baba, the Atomic Energy Establishment at Trombay was renamed as Baba Atomic Research Center. This happened in 1967. That time the Prime Minister, Srimati Indira Gandhi, visited BRSC And Dr. Ramanna was the director of physics at that time. So just to show that, different stages of Dr. Ramanna, I have shown you a 56 photo and now it is 67. And then, of course, the most important contribution of Dr. Ramanna was on the, he was taking the leadership role in the successful first nuclear explosion, which India did in 1974. This was the code name was Smiling Buddha. And this was the first underground nuclear explosion. Took place at Pokhran in Rajasthan, May 18, 1974. And you can see the crater which was formed after the explosion. Ramanna, of course, is remembered as the father of the Indian nuclear explosion program. He must have started this work from late 60s, and they were ready for this. And of course, once the Indira Gandhi gave the go-ahead sign, Dr. Ramanna and colleagues went ahead and did this experiment, and it was very successful. And immediately after that, you can see that Dr. Iyengar, Dr. Setna, Dr. Ramanna was director of BRSC, Setna was chairman, and Dr. Chidambaram, they are all sitting there. This immediately after the explosion. And one of the things which happened was, India became from a developing country to a developed country in nuclear science and technology after the successful peaceful nuclear explosion of 1974. You all know that after almost 25 years, in 1998, again, India carried out successfully nuclear explosions. And that time, Dr. Chidambaram was the leader of this program. And so again, the world took note of India's capability in different aspects of nuclear science and technology. Ramanna was the director of BRC during 72 to 78. Then, of course, he went to Delhi after that for another assignment and came back and then continued as director 82, 83. Then he was chairman of Atomic Energy 83, 87. And during this time, the Madras Atomic Power Stations, at 1 and 2, there are two reactors at Kalpakam. Both started delivering full power during Dr. Ramanna's tenure. And then the first fast breeder test reactor, it was also made operational during his stewardship as chair. And of course, Ramanna, as I told you, went to Delhi, and he was scientific advisor to the Raksha Mantri, Defense Minister, and he was also Director General at DRDO. And there in this new role, he was also transforming into DRDO, Defense Research. So he made it more challenging, and thrust areas were clearly identified, and steps were taken to promote inter-laboratory interaction and cooperation. Of course, they also put in some efforts for indigenous development of defense equipments. And then after that, there is chairmanship when he retired from the Department of Atomic Energy in 87. J.R.D. Tata had a new plan. He started the National Institute of Advanced Studies at Bangalore in IISc campus. And then he invited Dr. Ramanna to be the founder director of this institution. And Ramanna accepted it after his tenure at DAE. The aim of INYAS, the National Institute of Advanced Studies, is to conduct advanced research in multidisciplinary areas and provide short-term courses to administrators, managers from industry, government, and in several areas. You can imagine natural, social sciences, arts, humanities, history, economy, even consciousness. I believe Dr. B.V. Srikantan, former director, TIFR, was working on this aspect of consciousness I think at some stage when he was at NIAS. So the Ramanna remained there until 1997. So he invited many distinguished scientists and engineers to be part of INYAS, and so made sure it was put on a growth of. Ramanna had a brief stint as a minister in central government. I think when Mr. VP Singh was the Prime Minister of India. He served as a nominated member of Rajya Sabha during 1997 to 2003. As can be seen that in his illustrious career, Ramanna had probably was wearing different hats as a scientist, technologist, Director General DRDO, Chairman Department of Atomic Energy, Central Minister, Director NIA, and MP. You can imagine such a vast field of of a great interest to people. Such was his personality that people from different walks of life went up to him for guidance and advice. Two notable contributions of Dr. Ramanna, which we should mention and remember, are his contribution to development of skilled manpower for our Indian nuclear program and the growth of research in nuclear and solid state physics in the country. You know that BRC training school was started more than 60 years ago, again by Dr. Baba, and he entrusted the job of training school to Dr. Ramanna, and Ramanna took a keen interest right from day one, and at least for nearly 20-30 years, he was actively involved with this training school program, and which was the way we were getting scientists and engineers, the best scientists and best engineers in the country. And they were the people who were put into various programs, development of R&D of various programs, or nuclear power program in the country. And all the manpower came from this training school. And of course, this training school was also started to prevent brain drain, people going out of country and all that. So this was Dr. Baba's idea. So Dr. Ramanna nurtured this training school from inception, and nearly 10,000 scientists and engineers have come out of this training school. Of course, they have not only shouldered the responsibility of the nuclear power program. Many became director, chairman, and all that. And some of them went also to other programs like space and defense and all that. So the BRC training school has really contributed to generation of quality manpower, science and scientists and technologists. And development and sustenance of the nuclear program has all been due to, mostly due to the trainee engineers and scientists who have come out of this training school. Another one is that the Department of Atomic Energy supported nuclear and solid state physics symposia. They are also again being held for more than 60 years now, and again started by Dr. Baba and then sustained and nurtured by Dr. Ramanna. And Ramanna contributed to the growth of this nuclear physics and solid state physics research in the country through the symposium and otherwise. And he enhanced collaboration between DAE and universities. And some of you may know that the Indian Physics Association and the Pramana, the Journal of Physics, both came out after during the symposia deliberations. Ramanna took a keen interest in the symposia right from inception and participated in the symposia for more than 25 years or so. And I think young people like us those days, we used to enjoy Dr. Ramanna's concluding remarks. It will be very crisp, and we all were looking forward to that concluding session of the symposium. This is one of the probably the last symposium Dr. Ramanna attended or participated, and we requested Dr. Ramanna to inaugurate this symposium in 2000. It was held at BARC. So as you have, Ramana was Vice President of Indian Academy of Science. He was also President of Indian National Science Academy, President of IAEA General Conference. It's a rare and unique honor for India. He, of course, has, for his significant contributions, he got the Shanti Swarup Bhatnagar Award, Padma Vibhushan, Meghnad Saha Medal of INSA, then the R.D. Birla Award of the Indian Physics Association. And then he also got the Ashutosh Mukherjee Medal from the Indian Science Congress. As I told you, many of these things are available in the literature. So I thought one of the ways of knowing more about Dr. Ramanna would be to talk to people who had known Ramanna for many decades or who have worked with Ramanna for many years. So in that, I was fortunate. I contacted a few distinguished scientists. One is Dr. PC Suman, who is close to now 90. And he was a former professor of physics, BHU, and presently at Sri Sathya Sai Institute of Higher Learning. And this is what he says about his remembering Ramanna. A staunch nationalist, Ramanna was instrumental in bringing back to India many talented scientists. In fact, he says he himself decided against going to USA for a job. He had a job actually. Ramanna, in fact, persuaded him to accept a professorship at BHU, and so that is where he remained. His role in initiating and supporting nuclear physics in India is unparalleled and contribute to develop. Of course, Ramanna, I think in some committee went there and I think gave so much support to that 400 kilovolt accelerator coming up at BHU. He always was informal, even affectionate and considerate at human level, and he was exceptional. In fact, he was remembering Ramanna even went in his scooter to his house when Ramanna visited BHU. And I'm saying he was such a easygoing person. Another person I contacted was Dr. Chidambaram, former chairman, Department of Atomic Energy, and former principal scientific advisor to the Government of India. He worked closely with Dr. Ramanna, particularly in the successful conduct of the PNE, Peaceful Nuclear Explosion of 1974. So he remembers that Ramanna was responsible for his joining BRSC way back in '62. He was part of the committee which selected him. Ramanna had an uncanny way of judging people and entrusting them important R&D jobs. He was liberal in sharing credit with his collaborators. He also brought to my notice that seems Ramanna, being well versed in Sanskrit and also spiritual, he took time to translate the devotional Sanskrit poem Mukunda Mala by Saint Kulashekara Alvar into English and Kannada. Dr. Kapoor, a former director of physics group and D.A. Homi Bhabha chair professor. He was the first PhD student of Dr. Ramanna, and so he worked with him on the fission experimental program. So this is what he has to say. Ramanna was a scientist in true sense of the word. He kept himself scientifically active till the end. He excelled in devising indigenous experimental techniques. Once they wrote a paper, it seems Ramanna was staying at Anand Bhavan. I don't know, those who are familiar with Bombay, Anand Bhavan is a BRC quarters, a couple of kilometers away from Kenilworth, which is also another BRC quarters. Dr. Ramanna was staying at Anand Bhavan and Dr. Kapoor was staying at Kenilworth. And it looks like they had written a paper and Ramanna had some doubts or questions. So he didn't wait for the next day. So he decided to visit Dr. Kapoor at Kenilworth. He went there and Dr. Kapoor was pleasantly surprised to see Ramanna at his doorstep. And then they discussed about the paper and then Ramanna went back fully satisfied. He encouraged younger colleagues to discuss with him scientific topics without any hesitation and worrying about hierarchy. Another person I contacted was Dr. V.S. Ramurthy, former Secretary DST and former Director NAS. Of course, he was also fortunate to be guided by Dr. Ramanna for his PhD, and he worked closely with Dr. Ramanna on the mass distribution of the theory which they developed to understand the mass distribution of fission fragments. Always consider Ramanna as an excellent mentor, and he always used to say that, do your best and have faith in yourself. Ramanna was not a safe science man. He always dared to differ. If you went to him and said, I have carried out measurements and there is a problem reconciling my results with other existing measurements, he will say, very good, double check your measurements. If the discrepancy persists, then this is where you should concentrate. So according to Dr. Ramurthy, Ramanna always enjoyed having discrepancies and anomalies because he felt they were the precursors of new information. So anyway, I'm very thankful to all these people who could share with me some of their fond remembrances of Dr. Ramanna and their association. Ramanna, being a spiritual person, also had an opportunity to have a meeting with the great saint, the Paramacharya of Kanchi. Ramanna was interested in philosophy as science that time. He summarized his meeting with the Kanchi Paramacharya, His Holiness Shankaracharya Swamigal of Kanchi Mutt, who lived 100 years. And the Acharya's message to me was clear: to the person whose ignorance, etc., that real knowledge, God gives light equal to the light of the sun. And what better inspiration can be there for pursuit of science and philosophy? The material world has its laws, but human consciousness has a higher reality which can be understood only when ignorance is destroyed by real knowledge, even as the great Adi Shankara himself achieved. Ramanna has written about this meeting in Bhavan's journal. Of course, I have a feeling that if Ramanna had not continued in the Department of Atomic Energy, probably he would have ended as a great musician of great repute. Of course, everybody knows that Ramanna, in fact, he has a degree also in music, and he used to play piano, I think, even at a very old age. I think Tilak Ghosh or somebody reminded about Ramanna playing piano at Saha Institute of Nuclear Physics, I think when they opened the new auditorium. So it was his love right from childhood. In fact, when he came to India on Baba's invitation, it seems Ramanna was given 2 rooms in Old Yacht Club. That was the place where people were staying those days. 1 room for his piano and 1 for Ramanna. So, even Baba was encouraging Ramanna right from the beginning. So I've taken you through some kind of, reminiscence of Dr. Ramanna and what all he has done during his period. And in fact, I had an opportunity to receive him and bring him to BRSC in 2004 when we had a meeting at BRSC. So I had still pleasant memory of accompanying Dr. Ramanna to Central Complex at BRSC. And of course, he made several jovial remarks during the presentation of various people. And I could see his humbleness, at very close quarters. So Ramanna was a multi-faceted personality: a scientist, technologist, patriot, team builder, mentor, philosopher, spiritual person, and also a musician. And Dr. B.V. Srikantan, who is also almost similar age to Dr. Ramanna, has written a very nice book. Of course, Ramanna has also written an autobiography of himself. And Professor Srikantan, former director TIFR, who was at INYAS with Ramanna, he has also written a book about Dr. Ramanna. And he summarizes Ramanna in the words of Longfellow. He says, the lives of great men all remind us we can make our lives sublime, and departing, leave behind us Footprints on the Sands of Time. Dr. Ramanna was one such personality, and we fondly remember him on his 96th birthday. I am again grateful to Dr. PC Suman, Dr. Chidambaram, Dr. Kapoor, Dr. Ramurthy for sharing their reminiscences of Dr. Ramanna. We also thank Dr. Raut and Vivek Parker, both members of INYAS, for their valuable inputs about Dr. Ramanna's publications. I once again thank INYAS for this excellent opportunity to remember and speak about Dr. Ramanna, a great personality. Thank you.
Thank you, sir. It is indeed an excellent talk and about Dr. Ramanna and his life and achievement. So, if any questions from YouTube and Zoom, we can have. Let's see. Otherwise,
Of course, I see Dr. Ramurthy on the Zoom.
yeah.
One person who can make even some remarks about Dr. Ramanna because he had worked with him so closely.
Yeah. Hello, sir. Welcome, sir. Professor Ramurthy, welcome, sir.
Thank you very much. Yes, it was a very pleasant presentation to hear after such a long time and remember Dr. Ramanna. I don't think anything more I would like to add at this stage. We must leave this hall with sweet memories which Kailas shared with us.
Okay. Thank you, sir. Thank you. So actually there are only no questions from YouTube, only comments and suggestion, and then said that nice and excellent talk, and
of course, I just wanted to say that both DAE and DST, as a way to remember Dr. Ramanna, they have instituted this Raja Ramanna Fellowship. So both at DAE and at DST. So they give to distinguished scientists and engineers this Ramanna Fellowship. I remember Dr. Ramurthy used to say that DST Ramanna, one can take it until the person dies. There is no limit. Maybe it is changed now. But anyway, these two prestigious fellowships are named after Dr. Ramanna. Of course, one thing all of you know that the CAT, the Center for Advanced Technology at Indore, it has been renamed as Raja Ramanna Center for Advanced Technology. So again, to remember Dr. Ramanna.
Yeah. Okay, thank you, sir. Very inspiring talk, and nicely explained from his childhood to and his work, and along with his many leadership quality. Indeed, it's an inspiring talk for many young scientists and young students, and to learn from his many things from his life and work. And in fact, what we are doing the neutron science today, so he has already completed the 1960s and 70s, as I heard from you. So even though we go through many papers, we never know that how much he has contributed. It is really indeed an excellent talk, and you have spent a lot of time. And on behalf of INYAS and all the students, we thank you, sir, for your excellent talk, and really, and this will be available in YouTube, and in future also all the students, and basically the main aim of this forum to popularizing the scientific contribution of Indian scientists, to encourage young students and popularizing the science so that they can think of science as a career in future. That is the whole idea. And thank you, sir.
Thank you again. Thank you.
So we can leave now. Thank you for your nice talk. And then in future, any time we need, then we can request you for any, not necessarily this type, any other type of lecture. So it will be nice to listen you always. And you are one of our best teachers in many of this nuclear physics symposium and also schools. And nice to listen you also, sir. Thank you, sir.
Thank you, Prakash. Thank you.